Okay, the next step is basically, because we have error bars on the x and y variables, we also need to not only put in the line of best fit, but the max and min gradient lines, because an error on your data point means you've also got an error on your gradient or slope. And the IB wants us to consider this. This is tricky, especially in this case, because your error bars are very small. I think I may be able to draw them here. If these are remarkably small, it's important to say in your Word document that the error bars are very small to be visible, and it's very difficult to draw the lines of max, min, gradient. Okay, so that's really important to do it if you can't draw the lines. I'm going to make an attempt here. So to draw them, you click on layout, and you basically go to shapes, and I'm going to go to a straight line. So you know that this is difficult because they're so small. I'm going to start down here, and I'm going to draw my line up until this corner here. This will be my max. Okay, and I want to bring the lines back to test whether they pass through the origin too for later on. Okay, that's the first line, and this is the line of max gradient. Okay, back to layout. The next line, which is the line of min gradient, starts here and then goes over here. And this may take some practice, but it's important to get this as close as possible to where it should be resting. Okay, the examiners will look out for that when you submit your lab work at the end of grade 12. Okay, align it back. So, excellent. What does this tell us? Realistically, stand back and look at the big picture. It tells us that the best fit line doesn't pass through the origin. There is systematic error. However, there is a reading error or random error on your data points here. There are other errors, not only systematic. Based on these errors, which give the errors on your data points, measurements, give an error on your gradient, it's saying that there is a best fit line that can pass through the origin. Okay, the red line doesn't say that, but if you look between your max min lines, a relationship passing through the origin, let's say a line passing through the origin, can exist. It is possible, which means that there is a possible proportional relationship between average acceleration and height. What does proportional mean? A linear passing through the origin. Answer is yes. So one aim in your conclusion evaluation, especially, and you come back to this later, is you ask the question, is there a proportional relationship between your variables? Is there a proportional relationship between average acceleration and height? And the answer is yes. Although the red line, the line of best fit, doesn't pass through the origin, within the max min lines, a line could pass through the origin, which means you can support the relationship, which is proportional.